Hi folks, this is your Minute Math friend, and today we're looking at power functions, which would be any function of the form y equals x to the n. We're just going to briefly look at the patterns in those graphs. When we're looking at a positive odd number, like y equals x to the 3. So what the graph looks like depends on whether the number that's in the exponent is even or odd, positive or negative, and a whole number or a fraction. If it's a positive odd number, the curve goes through 0, 0. All these curves will go through 0, 0, and appears in quadrants 1 and 3. Remember, if we label these quadrants, it would go 1, 2, 3, 4. So quadrants 1 and 3 for the odds, whether it's x to the third, x to the fifth, x to the seventh, has a sort of appearance. Positive even, like y equals x to the 2, y equals x to the 4, that's going to look more like this. Both branches go up. This exists in quadrants 1 and 2. You might know that y equals x to the 2 makes a parabola. That's what we call that curve. Y equals x to the 4th is not a parabola. A parabola is very specific in its exact shape, but x to the 4th does have that both branches go up thing. It's just a little flatter at the bottom than a parabola. If we have a negative exponent, like y equals x to the negative 1, that would be like saying 1 over x if you're using your algebraic rules on negative exponents. We have what's called a rectangular hyperbola. This is a hyperbola, a function with two branches that aren't connected. And again, in quadrants 1 and 3, they get close to the axes. If we have x to the negative 2, x to the negative 4, x to the negative 6, we get those two branches not connected. They get close to the axes, but now they're in quadrants 1 and 2 instead of quadrants 1 and 3. Finally, if we have a fraction, if I had x to the 1/3, that will still be in, odds are always going to be in quadrants 1 and 3, and now it's kind of sideways. Instead of going like this, it goes like that. And fraction, there are no asymptotes, by the way. It does keep going on to infinity. It just gets there a lot slower than if it were y equals x cubed. For an even fraction, though, these are the weirdos. Instead of appearing in quadrants 1 and 2, as all of the other even ones have so far, it just simply stops at the origin, kind of springs to life out of that point. This function does contain that point. It's not an open circle. It is a filled-in circle, and it does go on forever in that direction, but it does not exist in any of the other quadrants. That's it for this 1 minute. I hope that you will come back and watch another one. And if you want a further explanation, click the full-length video that's in the comments.